So for the next one, I want to find the x and y intercepts of the following functions. So an x-intercept will be when y equals 0. When it crosses the x-axis is when y equals 0. And a y-intercept will be when x equals 0. So y-intercepts are sometimes easier to find. So I can say to find y-intercepts, I'm going to set x equal to 0. So f of 0 is equal to 0 plus 3, 0 minus 5, 0 plus 4, 0 minus 3. So that gives me negative 15 over negative 12, which simplifies to 5 fourths. So that is my y-intercept. And to find x-intercepts, I'm going to set y equal to 0. So 0 equals x plus 3, x minus 5, over x plus 4, x minus 3. So when is that fraction going to equal 0? It's going to equal 0 when the top is equal to 0. So I can focus in on the top there, and I can say that that's going to be equal to 0 when x equals negative 3 and when x equals 5. So those are my x-intercepts. So these are my x-intercepts. So negative 3, 0, and 5, 0. So those are coordinates of points. And then my y-intercept is 0, 5 fourths. Okay, so the next one, I want to find my y-intercept first. So if I set x equal to 0, I'm going to get 0 plus 2 over 0 squared minus 0 plus 3. So my y-intercept is 2/3. So the y-intercept is 0, 2/3. To find the x-intercept, I want to set y equal to 0. So if I say 0 equals x plus 2 over x squared minus x plus 3. And so I am going to factor the bottom there just to make sure. So I have x plus 2 over x plus, sorry. So it's x minus 3, x plus 1. No, actually the bottom doesn't factor. Anyway, it doesn't matter. So if I set that equal to 0, that means the top part is equal to 0. So that gives me x is equal to negative 2. So it just has the one x-intercept. So it's at negative 2, 0. We can stop there. Determine the point, if any, where the graph of the function crosses the horizontal asymptote of that function. So first of all, we need to find the horizontal asymptote. And so the horizontal asymptote is going to be, I'm going to look again at the leading terms. And so I see that I have the same degree on top and bottom. So the horizontal asymptote will be at y equals negative 4 over 1, which is just negative 4. And so if I graph that out, so at negative 4, I have a horizontal asymptote. And so I want to see where that function is equal to negative 4. So I can say negative 4 is equal to negative 4x squared plus 5x minus 1 over x squared plus 2. So I can multiply the x squared plus 2 over, and that gives me, so that'll give me negative 4x squared minus 8 equals negative 4x squared plus 5x minus 1. And then I can subtract negative 4x squared from both sides and add that 8 over. Well, actually, I'll add the 1 over. So I get negative 7 is equal to 5x. And then I can divide by 5. So x is equal to negative 7 fifths. So at that value, that's where it crosses that. So I can say the coordinates at that point are negative 7 fifths and negative 4. Determine if the function defines if the relation defines a function. So to be a function, I need to have that each input maps to only one output. Okay, so I'm checking each input. So I see the input -10 only maps to one thing, the input -2 only maps to one thing, the input 6 maps to one thing, the input 14 maps to one thing. So the first one is a yes. The second one, I can see a problem because the 3 and 4 are mapping to the same thing. No, actually, that's not a problem because 3 is mapping to one output and 4 is mapping to one output. So this is a function, yes. It is a function. But this, since they both map to 25, that means it's not a one-to-one function. So you may have talked about that in your class, but it is still a function, but it's just not a one-to-one function. So for this one, I can see that I have a problem because at -1, it maps to multiple y values. So this is not a function. For example, x equals -1 maps to more than one y value. Okay. Determine if the function is one-to-one. Give explanation supporting your choice. So k of x equal x cubed plus 8. So that function looks like this. So it looks like that. X cubed plus 8. So each input has only one output. So I can do this by looking at doing like a horizontal line test and seeing does each output have only one input. And so this one is one-to-one. Okay, x squared minus 6, I want to decide if that is one-to-one. So I can look at this graph. X squared minus 6 is going to look like this. It's just x squared, but it's shifted down 6. And so I look at any place here, I can see that we have, it is not one-to-one. Because I can see that I have two different x values that map to the same y value. The y value, y equal 1, has two inputs that map to it. Okay, this one again is not one-to-one because I have, it fails the horizontal line test. Use composition of functions to determine if the two functions are inverses. So we need to compute f of g of x, and if that is equal to x, then they are inverses. But I also need to compute g of f of x, and I'm looking for, does that equal x? So that's what I'm going to be doing on both of these. So let's start by computing f of g of x and see what we get. So if I plug g of x inside of f of x, I get 4 over, and in place of x, I'm going to write x plus 4 over x minus 1. Okay, and so this is a little bit hard to read here. So what I'm going to do here is I'm going to multiply top and bottom by the same thing. So it's just like multiplying by 1 in a fancy way. So I'm going to multiply this by x and that by x. And when I do that, I'm going to clear out that fraction in the bottom there. So I'll have 4x over, and when I multiply this x in, I need to multiply it in by both things. So I will end up with x plus 4 over x times x just gives me x plus 4 minus x. And so then I can simplify a little bit further. So I just multiplied by x over x to get that to work out. So then I get 4x over, and then I'll have x minus x, those add to 0, so I'm just left with 4 on the bottom. Then 4 divided by 4 makes 1, so I'm just left with x. So that's good. Let's try g composed with f. So if I put f inside of g, I'm left with, in place of x, I want to do 4 over x minus 1 plus 4 over 4 over x minus 1. And so what I want to do is I'm going to multiply by x minus 1 over x minus 1 to clear out the denominators in the top and bottom. And so when I do that, I'm left with, on the bottom, I'm left with just 4, and on the top, I'm left with 4 plus 4 times x minus 1. And so I'm going to simplify that down. I get 4 plus 4x minus 4 over 4. So that gives me 4x over 4, which is just equal to x. So it checks out. F composed with g is equal to x, and g composed with f is equal to x. So this is a yes. Okay. For the other one, I want to do the same thing. I want to check that r composed with s is equal to x, and s composed with r is equal to r composed with s of x, and s composed with r of x. Okay, so if I take s and plug it into r, I have negative 2 plus, and then I'm going to plug in 6x minus 2 over 6. And so that gives me 6x minus 4 over 6. So that one does not work. It doesn't give me just an x. So this is no. Each function is one-to-one. Show the inverse function. Give your answer in inverse function notation. So I want to find the inverse of this. So if I'm finding the inverse, I want to go backwards. So I'm going to treat my y as x and my x as y. My inputs and outputs are changing. So I can write this as x is equal to the cube root of 2y minus 5. And so I can go from there and solve for y. So I'm going to cube both sides. I can add the 5 and divide by 2. So I get y is equal to x cubed plus 5 over 2. And that is my inverse function. So I can say f inverse of x is equal to x cubed plus 5 over 2. So that is the function that will undo all the operations of the function f, so that it leaves x unchanged. Okay, so the second one, I can say x equals y minus 4 over y plus 2, and I want to solve that for y. So I'm going to multiply y plus 2 over. So that gives me xy plus 2x equals y minus 4. Now what I want to solve for is I want to solve for y. So let's just highlight the terms that have y in it. Those I want to get on the same side. So I'll have xy minus y is equal to negative 4 minus 2x. So I'll move everything that has y in it to one side. Everything that does not have y, I'll move it to one side. Now I can factor out a y. And then I can divide by what I've got there. So I have y equals negative 4 minus 2x divided by x minus 1. And so that is my inverse function. F inverse of x is equal to negative 4 minus 2x over x minus 1. Okay, the next one, evaluate the function at the given values of x, round to 4 decimal places if needed, show all work. So f of negative 3 is going to be 6 to the minus 3. And so I can plug that in and get an answer. So I did put that in my calculator, and I got round to 4 decimal places if needed. Okay, so I guess it's not really needed here. So I could do 1 over 6 cubed, and I know 6 cubed is 216. So 1 over 216 is an exact value. F of 3.8, so I could do 6 raised to the 3.8 power. That I'm going to have to get a decimal approximation for. So this is equal to 905.6799. Okay, f of square root of 13, so I'll have 6 raised to the power square root of 13. I could plug that into my calculator. And I get 639.2404. And 6 raised to the pi power gives me 278.3775, 278.37757, so it's 3776. Okay. Graph the exponential function f of x equals 4 to the x and use a table to find points to plot. Write the domain and range in interval notation. Okay, so I can use a table to find some points to plot. And so if I am looking at x and 4 to the x, so if I plug in 0, I'm going to get 4 to the 0, which is 1. If I plug in 1, I'm going to get 4 to the 1, which is 4. If I plug in -1, I'm going to get 4 to the -1, which is 1/4. So I can plot those 3 points just to get us started. So at -1, it is at 1/4. At 0, it's at 1. And at 1, it's at 4. The function's going to look like that. Okay. Write the domain and range in interval notation. So the domain will be all real numbers, so from -infinity to infinity, and the range will be from 0 to infinity. So it doesn't ever actually reach 0, so we need a parentheses on the 0. Given the graph of f of x equals 1/2 x, find the graph of 1/2 to the x minus 3 plus 2. State the shifts from the parent function. Okay, so this bit here is going to move it to the right 3, and this is going to go up 2. Okay, and so I can say this point here is going to go right 3, 1, 2, 3, and up 2. So that point's going to go here. This asymptote here on the x-axis is going to go to this point here. So there's my asymptote. This point here at -1, 2. So that point there is going to go right here. And so we're going to get a graph that looks like this. Okay, and so there's my function. Next, Kara needs to borrow $15,000. She has 3 options. So 5.5% simple interest for 4 years. So for simple interest, it's going to be principal equals interest times rate times time. And so after 3 years, it's going to be, principal times rate times time, excuse me. So the principal is $15,000. The rate is 5.5, so 0.055, and the amount of time is 4 years. So I can compute the amount of interest, that's the amount of interest. I don't know what that, the interest will be so it's going to earn $3,300 in interest. So that means that after 4 years, you'll have $15,000 plus $3,300. So after 4 years, this will be the value of this will be $18,300. So that will be the value after 4 years. Okay, what if we had 5.25% compounded monthly for 4 years? So we're going to use a different formula. So we have that the principal is equal to the original amount times 1 plus the rate divided by the amount of times we compound per year to the time times the number of times we compound per year. So we'll have that the principal will be equal to, or the amount that you have will be equal to 15,000 times 1 plus 0.0525 divided by, since we're compounding monthly, it will be 12 months per year, and then 4 years, so 4 times 12. So if I can compute that all in my calculator, 1 plus 0.0525 divided by 12 raised to the 12 times 4. I need to make sure that 12 times 4 is in parentheses, or I could just write 48. So I get 18,496.697, so 0.70. Okay, and then 5% interest compounded continuously for 4 years. So for this one, I'll have that P is equal to, so it's going to compound continuously for 4 years. So, so that's going to be the P naught times E to the RT. So it'll be P naught is 15,000, E to the my rate is 5%, so 0.05 times the amount of time, which is 4. So I'll type that in. And I get 18,321.04. And so for each one, the interest for each one, so the interest for that first one was 3,300. For the second one, the amount of interest was 3,496.70. And for this one, the interest was 3,321.04. And so those are the interests for each one.